In this lesson, I'm going to show you how to prove that two functions are inverses algebraically. If f inverse of x undoes everything that f of x did, what do you think f composed with f inverse of x will produce? Well, maybe you have a hunch, but let's try it if you aren't sure. And we're going to use f and f inverse from the first part of our lesson. So let's do the composition where we plug f inverse into f of x. So this means I'm plugging in -1/2 x plus 1/2 into f of x. So this would produce -2 times, and I'm substituting in the -1/2 x plus 1/2. And let's see what we get. Well, when we distribute, I would get x minus 1, and then I still have the plus 1. So this would result in just x. If you think about it, remember, one function did something to x, and the other one needs to undo those things. It's going to have to produce x. Well, let's check the composition the other way. Let's do f inverse of f of x. So this means into f inverse, I'm going to plug the original, which was -2x plus 1. So into f inverse, which was -1/2 x plus 1/2, I'm plugging in this -2x plus 1. I'm going to distribute, and that produces x minus 1/2. And then I had this original plus 1/2 I need to bring down. These cancel, and I get x. This leads me to my big idea that functions f and g are inverses if the following thing is true. If f composed with g of x is equal to g composed with f of x, and they're both equal to x. So you've got to check both directions and make sure you get x. If this is true, then you know for sure they are inverses. Okay, so I want you to prove that g of x, h of x, and w of x are in fact inverses of the original function. I am going to do g composed with g inverse of x, and then I'll go the other direction, g inverse composed with g of x, again using g and g inverse from our previous video. Okay, so for g of g inverse, this means I'm plugging 3 over x plus 5 into g of x. So I'd have 3 over x plus 5 minus 5. So this and this cancel, which gives me 3 over 3 divided by x. Well, dividing by a fraction is the same as multiplying by the reciprocal, so it would actually be 3 times x over 3, which would give me just x. So g of g inverse is indeed x, so let's go the other direction. So g inverse of, this time I need to plug in g of x, which is 3 over x minus 5. So this means into g inverse, I need to plug in the 3 over x minus 5. Okay, so I kind of have something a little bit ugly right here, but 3 divided by 3 over x minus 5 would be 3 times x minus 5 over 3. I got this plus 5 hanging out over here. This and this would cancel, so I'd get just x minus 5, and then I'd have plus 5. They would cancel, and I would get just x. So it works. All right. It's your turn to check to see that h and h inverse truly are inverses of one another, or prove it algebraically. So this means when you're asked to prove algebraically, you must do h composed with h inverse of x, and you must go the other direction as well, h inverse composed with h of x. So pause the video, try this on your own. When you're ready to check your answer, hit play. I get x when I compose both directions, so I verified algebraically that they are inverses. All right, it's your turn to verify that w of x and w inverse of x are inverses. Do your compositions both directions, and when you're ready to check your work, press play. Hopefully you've gotten the same answer as I have. If you are ever given two functions and you're asked just to verify or prove that they're inverses or check, what you, of course, can do is compositions both directions, see if you get x. If you do, you've proved beyond a shadow of a doubt that they are inverses.